Good morning. Myself Sivakumar, Assistant Professor, CSC Department, Vignas Nirula. Today we will discuss the first topic in computer networks, that is Introduction to Computer Networks. So we will discuss first network topologies, and then WAN, LAN, MAN, and then we will discuss reference model, that is OSI reference model and TCP/IP reference model. After that we will compare the OSI reference model with TCP/IP reference model. So first is network topologies. First is network topologies. A network topology is nothing but the structure of the network. So in a point to point. So for example, it could be a like this bus. Or it could be a bus. This is star. This could be a star. Either it could be a bus or a star or ring. So this is the system. So this could be a ring. Okay, bus, star or ring. So these are the different okay. So this is about the network topology. So either it could be bus or a star or a ring or an intersection of rings. So one more ring here, like this. Okay, so basically these are symmetric in nature. Okay, so this is about the network topologies. And next is different types of networks. Next is different types of networks. That is, first is LAN, that is local area network. LAN is nothing but a local area network. Okay, so what is this? What is this LAN basically? So there are different types of networks here. If you see here, so either it could be a LAN, either it could be a WAN or LAN or MAN. So LAN means local area. So how these are classified? Local area networks. MAN, metropolitan area network. Metropolitan area network. WAN, it is wide area network. Wide area network. So how these are classified? So these are classified based upon the size and transmission. Okay, size and transmission and topology. Okay, these are the three ways. Okay, so that means suppose if the size is 0.1 meter, then data flow machine, so those are the machines. And if it is a 1 meter, multi computers. I mean computers having more than one processor. If it is a 10 meter, if it is a 10 meter, then room. 100 meter, building. 1000 meter, city. 10,000 meter, country, continent, like that. So if it is a 0.1 meter, 1 meter, 10 meters room, 100 meters building, 1000 meters city, 10,000 meters country and continent and continent. So this metropolitan area networks is 1 kilometer. Sorry, not this one. This city is nothing but the metropolitan area network. That is the size. Okay, and whether it is a room or a building, we call it as a local area network. Whether it is the connection is in a room or a building, we call it as a local area network. If the connection is within a city, we call it as a metropolitan area network. And it is country or continent, then it is a wide area network. Across the globe, we call it as a wide area network. So this is the classification based upon the size. Transmission. So basically the transmission for local area network is 10 to 100 Mbps. Small b, not 100 MB. Here mega means 10 power 6. Okay. So 10 to 100 Mbps is transmission of LAN, local area network. Local area network. And topology is either star or a bus or a ring. So different topologies are supported by each of these networks. So basically we have to study here what is present in local area network and what is present in metropolitan area network and what is present in wide area network. So first is metropolitan area network. So here there is a concept called distributed queue dual bus. So DQDB. So this is the concept. So which is present in metropolitan area network. So from either of the ends we can transfer the data from either from one end. Okay, that is right corner on down or top left corner or bottom right corner. So we can transmit the data either from top left corner or from the bottom right corner. So that is nothing but a DQDB, the distributed queue dual bus, like this. Okay, so this is about the metropolitan area network. And in the local area network, so we have two types, whether it could be a point to point or broadcast. So broadcast means broadcasting means sending a message to all the machines in the network. So that is broadcast. So multicast is a special case of the broadcast, that is only to a specific group. So only which is specified in the address field. So only to a specific group, so that message will be delivered. So broadcast means to all the machines. So there is separate address. So 255.255.255.255 in IPv4. So like that, there is a specific address designated for the transmission of the transmit to local area network or wide to the local area network. So that is nothing but the broadcasting. Okay. So whereas in case of multicasting, only to a specific group it will send the message. So that is nothing but the multicasting. To a specific group it is multicasting. To all the machines in the network it is nothing but the broadcasting. Okay. There are two types of network, is a broadcast network or a multicast network. Next is point to point network. So another important point is point to point. That means one machine is connected to another machine and that machine is connected to another machine in sequence. So that is nothing but the point to point connection. Only one machine is connected to another machine. So that is nothing but the point to point. And here in case of WAN, LAN and MAN, so if you go to wide area network, so there is again further classification. That means a wide area network is nothing but a network with subnet, okay, and these are connected to, systems are connected to each other through subnet. What is a subnet? A subnet is nothing but a transmission lines and routers. Transmission lines and routers. So this is the path. So from this machine, the information transfer, the packet is transferred from here to this router, and router will routes the packet to another router, and that router will route the package to the destination. So this is the source machine and destination machine. So the information is transferred from one machine to another machine through subnet. So subnet is nothing but a collection of routers and transmission lines. So that is the definition of the subnet. So this is one of the topic in the wide area network. Wide area network. Okay. So these are the different types of network topologies which we will see now. Okay, so there are two types of systems here, centralized and decentralized. So this is what to discuss here. So what is meant by centralized and what is meant by decentralized? So centralized means one of the system will control the arbitration. That means, suppose in case of a point-to-point connection, so more than one system is connected to the more than one system is connected. So that means any system can request for a channel. Okay, any of the system can request for a channel. So in that case, due to competition, only one channel will get the access to the, only one system will get the access to the channel, but not all. So suppose if more than one system try simultaneously to access the channel, so which one should get the access now? So that will be decided by the centralized algorithm. So there is a centralized server which decides which system will now get the chance to access the channel. So that is decided by this centralized. So decentralized means so it is not, so one of the system, one of the component or one of the network, one of the system in the network will act as the arbiter, and it will decide which one should select, which systems now get the chance to for channel allocation. So that will be in a decentralized. So decentralized means everyone will participate, but whereas the difference between centralized and decentralized, there is a performance bottleneck in case of centralized. That means every time we rely on the centralized system. Okay, so if more than one request, like hundreds of thousands, the server will be overwhelmed. Okay, so there is a performance issue in case of centralized, whereas there is no such performance issue in case of decentralized. So there is a difference between the centralized and decentralized static or dynamic. So here 802.3 is a switched Ethernet. You see here 802.3 is a switch Ethernet. Okay, and 802.11 is Wi-Fi. 802.11 is Wi-Fi and 802.3 is the Ethernet. So static or dynamic medium access. That means static means fixed. So that means the configuration is fixed. Whereas in case of dynamic, the configuration is dynamic. That means at runtime only we will decide, not fixed. There is no fixed route. The route is decided by at that particular point of time. So that is nothing but the dynamic. Whereas static is fixed. That means all the path is established in before the beginning of the action. Okay, that is about the static. So what are the characteristics of LANs? So characteristics of LANs are private owned. What are the characteristics of LAN? Private owned. That is first, because LANs are available in a private organization, small size, transmission technology and topology. So here it is a cable and it is a ring. Okay, so it is a bus or a ring or token ring. So like that. Okay, so this is a bus. So this is a computer, and this is a cable, and this is a computer, and these are the computers which are connected through by means of a ring. So these are nothing but the, and either these are nothing but the local area network, and here the speed is up to maximum 10 GB per second. That is the maximum speed which we can achieve using LANs. Okay. So privately owned, small size, transmission topology, transmission technology and topology. Okay, these are about the LAN. Next, these are the different characteristics of the LAN. So first one is small size. We know it's a range from 100 meters. Transmission technology is either it could be a bus, a topology bus, or a ring. Okay, so transmission technology single channel, and the data rate is 10 Mbps. That is 10 power 6, 10 GB per second. 10 Mbps means 10 gigabyte per second, which is 10 power 9 bits per second. 10 power 9 bits per second. And channel allocation of broadcast networks, whether it will be static, that each channel is allocated time slot, or dynamic. Okay, that means in round robin fashion. So every system in the channel will get the access to the channel in round robin fashion. So that is nothing but the static allocation. What happens if a particular machine is not up, that means down at that time? So that means the time slot is wasted. So that type of situation not arises in dynamic. So only those which are required will be allocated at the runtime. That is nothing but the dynamic. Next, metropolitan area network. So metropolitan, so we know that metropolitan area network is again a man, nothing but man. So that means it is equal, I mean, it is relevant to cable TV. So like here, so antenna is there, junk box is there, head end is there, internet is there, and this is the environment. So where we can have the man environment. So WiMAX 802.16 is another example of using this metropolitan area network. So 802.16. Okay. WAN, that is wide area network. WAN is nothing but wide area network. So that means WAN that connects 3 branch offices in Australia. So one is in Brisbane, other one is in Melbourne, and other one is in Perth. So 3 branch offices in Australia is connected by means of WAN, and the transmission lines may be telephone wires, optical fibers, or wireless satellite links. Okay, so this is a transmission line, and this is a transmission line. So either it could be a telephone wires or optical fibers, okay, and satellite links. So this is a satellite link. So like that, the transmission lines could be any of these 3. So this is supported by the wide area networks. So the branches are globally distributed globally. Okay. So this is another example of WAN using a virtual private network. So using virtual private networks also we can build the WANs. Okay, WAN using ISP. So this is a ISP. That is, ISP is nothing but internet service provider. So it provides the transmission lines. So this entire thing is ISP, internet service provider. Internet service provider. Okay, so that is this again belongs to a WAN. So WAN is nothing but a ISP, that is internet service provider. Network topologies. So we discussed in the beginning. That means we have different types of network topologies. So this is a ring. So this is star. Sorry. This is star. This is a ring. this is a tree, this is a complete graph, this is a ring intersection, and this is irregular. Okay, so different types of network topologies are available in computer networks. Either it could be a star or a ring or a tree or a complete graph or a ring intersection and irregular graph. So the name itself suggests, so ring means where the computers are connected in the form of a circle and forms a cycle, and tree means there are no cycles, so the connections are free of cycles, and a star means where one is, 1 to n, so one connection to n connections is possible in star. Complete graph n into n minus 1 by 2, so those many connections are possible from one node to another node. Okay, so here there are 1 2 3 4 5 6 7 8 nodes are there, so 8 into 7 by 2, so totally 28 links are there in the complete graph. Similarly in ring intersection, so one ring is concatenated with another ring, so that both the links are intact with each other. And finally irregular, that means there is no regularity here. Okay, there is no shape, it is neither a circle nor a ring nor a star, okay, so nor a tree nor a complete graph, so it is irregular, random shape. Okay, this is about the different network topologies. Okay, so that's it. Okay, so before going into next topic, so we have to discuss about the WANs. So a subnet in WANs. So what is subnet? So I already discussed it. So subnet is nothing but it is a combination of transmission lines, okay, and switching elements. So the switching elements is, what is switching element? So data switching, data exchange switches. Either it will be data exchange switches, okay, or packet switching, switches, or intermediate systems. What do you call intermediate systems? They are totally three switching elements. Either it will be data exchange switches or packet switches or intermediate systems. So this is nothing but the subnet. Subnet is nothing but a collection transmission lines and switching elements. So transmission lines are these are either channels or trunks or circuits. That means where the bits are moved, on which the bits are moved. Then nothing but transmission lines. Switching elements. So these are special computers where data switching can happen, packet switching can happen, or these are also called as a intermediate systems. And router. So as I already showed in the diagram, so if this is a subnet, it consists of transmission lines and routers like this. Okay, this is nothing but the transmission lines and routers. Okay, clear? So we can use store and forward approach here, or packet switch mode. So store and forward means whatever the data comes here in the subnet, that is stored here, okay, and then forward to the next router, and store here and forward to the next router. Like that, the information is transferred from the source to the destination. So this is nothing but the store and forward. Okay, store or packet switch. So packet information is stored in the form of packets. Okay, that is another name for the store and forward or packet switch network. Okay, so packet switch or store and forward. So this is a diagram, so depicting the wide area networks. Okay, so sending host, this is sending host, this is a receiving host. In between there is a router, there is a subnet which consists of transmission lines and routers. So A, B, C, D, E, all these are routers. So now the packet from the sending host travels this path. That means comes from the sending process, routes to the router A, and then routes to the router C, and then routes to router E, and then received at the receiving host, that is receiver process. So it will not go to the B and D. So it will go directly from A to C, C to E, and E to the receiving host. Okay, so how this decision happens? So which to which router then the packet should be next forwarded to? So that is decided by the routing algorithms. That is decided by the routing algorithms. So routing decisions are made locally. So a stream of packets from sender to receiver, nothing but a virtual circuit. Nothing but what? Virtual circuit. Okay, so this is about the one pictorial representation of subnets, sending process and receiving process and routers. Okay. Okay, so we'll stop here and we'll continue this topic in the next lecture.